That's the best thing with industrial automation. That's why I know I will never go back to the traditional IT world. It's just really nice to see things move, big machines move. And it gives some nice feeling inside where you write software that controls something that costs millions or potentially billions of euros. When you go to bed, it just feels, okay, that was nice. That was a good day.
Hi, Jakob. Lovely to meet you. We were just talking about a project you did, a YouTube collaboration that sounds fascinating and rather unique for a software engineer. Could you tell us about it, please?
The project was a project together with the YouTuber Mark Rober, which is kind of like he's quite a big YouTuber, I think. He's got over 70 million subscribers. So doing videos about primarily scientific related stuff, super interesting. And they contacted me, Mark Rober and they're a big team, right? It's really a whole company. Like when you meet this big YouTubers, you really realize like it's not just one person, it's a big, big organization. They contacted me and told me that they're gonna do a video. They wanted to create a robot playing against a big football guy. And I thought, who could that be? Could it possibly be? And in the beginning, there was lots of secrecy and DAs and everything in place. But we ended up building a robot goalie that was supposed to play against Cristiano Ronaldo. So I'm not in any way interested in football or anything, but I thought that was really, really fun. So we did this project together where we included some PLC control systems controlling this robot goalie, playing against him, together with some vision systems and some additional stuff to track the ball and everything. And so very, very interesting project for if you have a software background, because there's some very particular software challenges involved in developing something like that.
So I guess some of those software challenges probably involve computer vision. How do you move the device? How do you make it respond? So which were the ones that you were particularly focused on and which were the hardest to deal with?
I was primarily focused on the motion control stuff, so the control system that actually moved the goalie. For the vision system, we had an external system, which basically did all the calculations and everything for us, because this has to go fast. Like from the moment Cristiano Ronaldo's foot touches the ball, from it touches the ball until it's at the goal, it's tops 250 milliseconds. So everything has to go insanely fast. So I was primarily focused on the motion control. So what I basically got was move to this position. And then we had to do the motion control to actually get that in the shortest possible amount of time, which, if you just look at it like that, it doesn't sound that complicated, but the work, initially it sounded like quite simple, but then you kind of start to define the acceptance criteria. What is it that we want to do? What should this do? What are we going to do if we get an error here? What are we going to do if the acceleration doesn't go as fast? What if the position changes? What if it does a curve ball? What if, there's a lot of what ifs. So you kind of start to define the acceptance criteria. What are the use cases? And the complexity explodes.
So 250 milliseconds probably sounds a long time to anyone dealing with high frequency trading and a very, very short time to anyone building web and mobile apps. I'm actually thinking that it's a really short time when you think about handling that computer vision and then physically moving things. We forget that physically moving things takes a lot of time. How do you handle that? And what are that 250 milliseconds was actually available for you to, like, we need to move from here to here. How do we do that? And how can the thing physically move that quick?
I got around, I don't remember the exact numbers, but I got about 80% of the time available, because there's some time where the signal has to go from the system, the vision system, and until it does have to do some internal calculations, and then it has to send a signal over a very proprietary protocol over to the PLC, the programmable logic controller, which is the actual control system controlling this. Then we got around 200 milliseconds. And the way we can kind of realize this, this is actually quite a common thing, because in industrial automation, it's kind of common often that you have to do stuff really quick. When you have, for example, if you're going to stretch a film for production, if you're going to stretch a film and you're going to grind it with something like the control loop to make that film really, really tight, we're still talking very, very tight control loops, like sub-millisecond usually. And sometimes we're talking about, I'm working in another part where we're controlling a big telescopic mirror. We're talking, microseconds. It's very, very fast cycle times. But this is kind of like the industrial automation hardware and software takes care of this for us. Like we literally use commercial off-the-shelf equipment for industrial automation to do this. So the challenges was here really not so much on the side where we have to run the cycle key to make this evaluation. It was more about the tuning of the drives. So these are the big things where the actual motors are connected to. So the drives is like, we don't talk directly to the motor like this video. The video was very simplified. Like this video said, we send a signal to the motor. No, that's not what we're doing. What we talk is to these big drives that you connect kilowatts of power to. And they, inside there, you have to do a lot of tuning to, because you basically have to configure, this is the mass we're going to carry. And we want this acceleration, and we would really not want that mass to evaporate. Like we don't want to shred it, which, I can't say everything we did during the testing phases. It was interesting, but there were some mishaps, right? Because when you tune these things, like the forces involved here. I mean, you saw the video, like how fast it goes. The forces involved there. If there's some things that are not perfectly tuned, then everything just gets shredded. So, yeah.
So how much modeling and computer-aided design do you have to do before you build something like that versus, figuring it out and trying it for real must be quite expensive?
Yeah, no. In this case, I would say most of it was trial and error. It was a lot of trial and error. So I must say, Mark Robert's team is fantastic. They're amazing. The people I got to work with there, because I'm very focused on the software side, like define the architecture, the acceptance criteria. We get the signal from the vision system here. What do we do? How do we process it as fast as possible? How do we minimize the delays? Mark Roberts' team were working with the mechanical system, right? And I was very impressed by these guys. But we did a lot of trial and error, very late nights, very late evenings, doing all of this together. I wouldn't want to say there was some modeling done, but most of it was trial and error. We saw, okay, this connection point where we attach the goalie to, it's not strong enough. We have to make it a little bit stronger. So yeah, it was more trial and error, I'd say, than whatever the scientific approach is. This was maybe less scientific from that perspective.
How does that then compare to industrial automation when you're actually doing this in factories for machines?
I would say it was very similar. It was very similar. The difference maybe was that the kind of software and infrastructure we built around it was not what you would traditionally call industrial automation. So we used industrial automation infrastructure to do this. But we don't have any need for infrastructure about maintainability of the system afterwards, which is a thing that's very big in industrial automation. Maybe we're going to talk about it, but when you deliver a system like this, it's really important that the person that's going to maintain the system after you isn't a full-fledged software engineer that talks, Git and interfaces and dependency injection, and you're not on that level when you hand it over. This system we developed, it was really like we used, we did it with test-driven development. We had all of these things. We tested the interfaces. I did some integration testing and all of these things. That was the big difference, I would say. On the rest of the mechanical side and everything followed very principles of, the hardware is basically standard industrial automation software, industrial automation hardware.
Okay, cool. So let's talk a bit more about industrial automation, because a lot of software engineers these days, particularly on social media, are left with the impression that software engineering is building websites, maybe mobile apps, and maybe a bit of back-end engineering to support that. I find a lot of people aren't aware that software exists in many, many fields, doing all sorts of things, and industrial automation is one. So can you tell us a little bit about what is industrial automation and what's the role of a software engineer in working in IA?
Well, on a short term, industrial automation is basically replacing what people used to do manually in factories and automating that. So through control system, robotics, PLCs, automating the manufacturing. That's traditionally what industrial automation has been. There has been a lot of it's been like an equal sign between industrial automation and manufacturing. Nowadays, the processes and equipment and software for industrial automation is very much used in other projects other than manufacturing. Like the Mark Rober project, of course, that was one example, but I'm also involved in some scientific projects with telescopes and that go to Chile. So I really see this industrial automation getting out there more and more in different places. In terms of your other question there, because there were two questions, with the software side, the role there is that traditionally, the people that have worked in industrial automation from the software perspective might not have had a software background. It has been mechanical engineers, electrical engineers, automation engineers, and others that have had some basic introduction to software, but might not necessarily apply the modern software development practices. It's more something like it's an afterthought, that the software part for people. So this changes now, and right now the acceleration is. I've been in industrial automation for about 15 years. And I would say it's in these 2-3 last years where more and more of the software side is getting into industrial automation. So it's a growing market for people working with software development.
And for people that are working in software in industrial automation, what's the typical operating system they're going to be dealing with in targeting? What's typical programming languages that you might use?
Well, it's actually a good question, because for the biggest brands, it's kind of the operating system. Everything is not everything, but it's very common that they're using something custom. So it's very locked down. It's like you have to spend quite a considerable amount of time to even figure out what is running underneath it. It's very much custom built. Some of them use Linux, and then they have a real-time patch. The one I use is actually primarily using Windows as the runtime operating system, which sounds weird. But then you have a real-time part of it. It's a kernel module you're basically loading to get the deterministic real-time stuff. And that's really the interesting things with industrial automation, where the operating system is one part of it, but it's everything around that's more interesting. Like, how do you program them? Because you of course you need the real-time deterministic stuff. You need the real-time network communication, right? Because you can't just use standard office networks with standard Cisco switches and stuff. You need something different to get the, you don't care about I want a 10 gigabit connection. That's not what you care about. You care about, I want to update my data every 100 microseconds with 1 or 2 microseconds jitter. I want it to be very deterministic. That's what matters. But the difference here is kind of like the engineering side is very, very different, because here it's a lot of very proprietary software. So while on the PLC side, you have a very locked down development environment. You don't have this openness of what you have in the IT industry. And it's locked down in the sense that you're using the tools that the manufacturer of that particular hardware tells you should be using, but also in terms of programming languages. There is a standard for industrial automation, and the programming language is called IEC 611.31-3, which involves a couple of programming languages, but it's very open how you interpret that, how that programming languages should look like, and how you integrate them into your development environment. That's vastly different. So if I would take a web developer today, and I've done this because I do a lot of pair programming. I have the luxury to work with a lot of young people, which is one of the best things I know. I take a web developer and I put them into the PLC environment. They're really gonna be frustrated. Like that's the short version of my answer. Yeah.
So they're going to find the whole development environment, the language is very different. So I guess I want to come back to what you mentioned several times, but before I go there, there's a lot of hype around AI at the moment, and AI is going to replace software engineers, and it can do Python or JavaScript or whatever. It's a kind of big trending language at the time. Are you seeing any of that in the languages that you're dealing with in industrial automation, or is it not really touched that area yet?
Yeah, so I'm going to try to avoid to get too political here, because AI is this really sensitive part here now in LLMs. By the way, I love LLMs. They amplify, like if you have good practices, whatever you want to say it, I really feel the LLMs really amplify that. So I feel they're really useful. In industrial automation, this is related to what I just said. The development environments are very closed. This means that, for example, let's take the biggest, one of the biggest brands for industrial automation in Germany, and actually in many places all over the world. It's called the company is Siemens, and they're doing this development environment called TIA Portal, which is the biggest one. Now, the source code storage and everything is just a big binary blob. Like everything is locked down in a very proprietary format. And the problems, obviously, for this is when you're going to involve an LLM, an agent, to look at this or work on it, it can't. You're basically dependent on making an interpreter or something between yourself, or you're dependent on using the manufacturer's tool, which at this point in time, they haven't really gotten anywhere close to where maybe you wish they were. So to answer your question, it's very hard in industrial automation today. This is, however, changing quickly. The big brands are slowly transitioning into using clear text code, which, and again, we have to remember here, we're talking about in industrial automation, you have structured text, which is one programming language. The other languages are graphical. So you use the most popular one in the US, most of my clients are Americans, they use something called ladder diagram, which is graphical. And, just working with that format is just a little bit harder, obviously, for LLMs than it is for. With that being said, principles still apply. So I still can define, help me write a test case. It's still going to be able to do it, but plugging that into the development environment is a little bit more work.
And the thing I really wanted to pull out is you said real time about a dozen times then. This is a subject that is hugely misunderstood in software engineering. People will talk about they want their website to render in real time and stuff, and that's not real time to me. I studied computer science at university, and real time had a very definite meaning, which seems to have been lost in a lot of software engineers that don't know. So you can probably explain it better than me, and you probably have real experience of working in a real-time environment.
Yeah, that's right. I mean, it's very contextual, right? In a sense, I would say, because of course, yeah, real-time. As an automation engineer, I wouldn't say 250 milliseconds is anywhere near real time or whatever that might be feeling. But if I open a web page and I open it and it loads in 200 milliseconds, like I might feel, for me, that's real time. The context, however, here is for industrial automation, it needs to be deterministic. So you want to have something that executes deterministically every time within a certain time frame and not longer than that. So and this time frame of execution is typically considerably shorter, maybe, than what you might think in other industries or in other fields. Because when you work with industrial automation, the big reason why you would take something like, so this is a PLC, right? The big reason why you would take something like this and put it into the control system is because you're going to do something like motion control. And when you do motion control, you have something moving like the robot goalie, probably something for manufacturing, a big 6-axis robots. You need to know that you need to make sure that the loop of feedback is deterministic. The feedback loop is just much tighter.
So if I've understood that right, then taking your example of stretching a film that you mentioned earlier, that to me would be what I would think of as hard real time. You need to stop stretching that film at precisely the moment, because if you go over by 1 or 2 milliseconds, you might tear it apart. So that's a hard real-time constraint that you have ruined something and it's no longer useful if you miss that. Whereas we also have a soft concept, which I'm not very good at explaining, and then there's realistically what we've got on a website where we just really like it to be within a few hundred milliseconds, because then it feels good. But it's still useful if it takes a second to load our web page. It's still usable if it takes a minute to use our web page. It's just frustrating where, as you say, with an industrial robot, if we're stretching something, if we make some wire, we're cutting something out, milling away at something. If we do that for a millisecond too long, we might destroy the material, we might destroy the machine, and that's waste and expensive.
Exactly, and that has an effect. That has an implication also on when you. So if you are a web programmer, let's take that, because I think this is really interesting. I guess a lot of people coming from the web industry might watch this. If you come from that and you get into industrial automation where you have a real-time system and you have these constraints, right? Because this puts constraints on your programming. You see this in the programming languages, right? Because there's a lot of things. Let's take one simple example: dynamic memory allocation, right? I mean, in probably most people don't even think about it, right? When I use Python, I create an object, and I don't even understand what. Am I sure this object is the object I think it is? And somewhere in the background, I guess it does some memory allocation somewhere. Like, I have no idea, right? It does something. It's always magic for me. In PLC programming, that's very constrained. Like, if you do dynamic memory allocation, then people will frown at you. Like, why are you doing this? Why aren't you just allocating an array of 10,000 elements, even though you only know you're going to use 100? Just make it big enough so that we never have to think about this. So, and I think this is really the interesting things. Like you see, when you have this constraint that we have to guarantee that this will not take more than 1 millisecond to run again and again and again, over and over again. We, on the language and on how I use the language, it puts this constraints on me. I think this is a very, very fascinating thing to see, because this was one of the things when I got into industrial automation. I had never worked with real-time stuff before. I got into industrial automation and I realized, okay, this is the reason the language is designed this way. This is the reason why if I use the new operator, the compiler will basically scream at me and say, are you sure you want to do this? Do you know what you're doing? But then it's explicit about it. So yeah, that's something related to this topic.
Yeah, it's a very different environment when you're trying to hit actual genuine real-time boundaries, isn't it? You have a lot more thought of pre-allocating memory, avoiding anything that, as you say, is non-deterministic, which memory allocation very often is. What are kind of the other constraints apart from memory allocation that you face as a programmer that we might not have seen as a web programmer or a backend programmer?
Yeah, one of the things is definitely related to the platforms on that you're working on. So we have this horrible thing where a couple of companies have, I'm not going to say monopoly, but close to, what is it called? So English isn't my primary language, as you probably figured. Oligopoly or something. When there's a few big players.
Yeah. Okay. Duopoly or something.
Yeah, exactly. And the thing is, like, the hardware is very, very constrained for the bigger brands. So typically when you work with a PLC, you're not talking about, I have 5 gigabytes or whatever my virtual machine or web server has. You're talking for real-time memory, the stuff where you can run, where you can put your real-time variables in, so to speak. We're talking sometimes kilobytes or megabytes. But then you kind of have to, you get into this thing where you choose a control system and you're gonna, it would be nice to have maybe 40 megabytes. And you realize, if I want that costs me 50,000 euros, to get a controller for that. It's and there's no reason for it to be like that. There's other vendors now that are doing something called PC-based control, which is primarily what I'm working with, where you can kind of have more commodity hardware, slightly industrialized. So it runs on typical industrial voltages, 24 volt, and it's hardened, so to speak, in the terms of where the environment where it's going to run, but they still use typical, PC memory, so to speak, where you can just use much more. But this is a big difference from going from web development, where you, for most platforms, have to really think about how much memory you're using.
So an obvious question, I think, for anyone that's not familiar with this environment to ask here is, why do you buy this kit off those big companies? Why not just buy a Raspberry Pi?
Absolutely.
For $100, you can get 8 gig of RAM and a fast CPU.
Yeah,
you can program it in Python.
Yeah, you have to think about the end user. That's the reason. That's the short answer. You have to think about the end user. First of all, the machine that this is probably going to control. Typically, I mean, I mentioned this number, 50,000 euro. I mean, I spent not that much on one PLC, but close to it at one point. This is pennies for most of these applications, right? Even these numbers. When you put it into an industrial automation environment factory, like I worked on one project where they produced stuff that was more than 50,000 euros per hour, so it's like, and this has to run 24/7. So the cost is typically, it's not a big concern. But the other thing is, of course, it's about the education. I told you, like, the people that will maintain this are typically not people with a major in computer science, right? It's people that are not mechanical engineers, there's maintenance people, right? They have some education, but they have to be able to potentially make changes in the software for whatever reason, because the system is going to be around for a while. From time to time, I visit clients and they have something that has been running there without problems for 30 years. So in that context, the Raspberry Pi idea, it kind of, it just doesn't make much sense in that context. But I fully understand. I mean, and I agree with this. I agree with this context, but there's still many things in industrial automation that generally are bad, even with this in mind. It's not so much about the costs; it's more about on the software side. There's a lot of practices there that could really be improved. But the reason you won't see Raspberry Pis is this. With that being said, there is actually a company using Raspberry Pis and industrializing them, hardening them, so to speak, and taking a PLC compiler from another company, an SDK, and integrating that into a Raspberry Pi ecosystem more. So there is this option.
Cool. And again, you mentioned PLC a few times there. A lot of people coming from a wider, web or like background won't know what a PLC is. And so could you explain that, please, Jakob?
Yeah, the short one is a programmable logic controller. The reason PLC exists is because at some point in time you created these control systems with electrical stuff like relay logic. Literally, you had relays and timers and different electrical components. The programmable logic controller is that, but running everything in software. So you have a controller where you can wire in sensors, actuators, temperature sensors, pressure sensors, and then you can control a robot or a motor or a drive or cylinders, all kinds of actuators, and you program that through software. So it's something that you apply. It's a device you need when you're working in industrial automation. You typically don't go and buy a Raspberry Pi, or you don't go and buy a Dell computer to control these plants, because as I told you, there's it's kind of like standardized on what kind of equipment you're going to use. And I mean, that's really important because the people that use these systems, they typically have training in a couple of brands, and then with these brands, it's not just the programming part of it, but it's also all the hardware, all the infrastructure around the hardware. So
yeah, and as you say, these machines that they're controlling are very, very expensive. They're looking to learn 24/7, and they're potentially dealing with stuff that's potentially quite dangerous or expensive if it goes wrong. I was lucky to visit a local factory near me that makes weightlifting equipment. And I was amazed at how complex the machinery is there that's going through building, just simply milling weightlifting plates, 20-kilo plate, but milled with the precise tolerances required for a competition standard. That's a massive multi-million-pound machine that's doing that. A machine that's milling Olympic weightlifting bars. That's, again, incredibly precise how well it's cutting. Again, to get the weight to competition spec within the precise weight standards, to get the knurling just right, to keep the strength there while it's cutting into things. Again, millions for each machine. And it's really impressive how precise they are. When you see how quickly some of these things are spinning, you need that control. And I can imagine if you go 1 millisecond on there, you're going to take a chunk of metal off that you don't need and completely mess everything up.
Yeah, some control loops are very, 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 very short. Especially when you start to talk about, using a load cell or something where the physical process it controls is quick. If you use accelerometers or something, and some of these control loops are insanely short. But I mean, and this is actually, maybe I'm getting a little off drift here, and then you can cut this out from the video. But my biggest issue, so yes, you're absolutely right. Everything you just said there, and you pointed to something very important. It controls something really big and complex, and typically the end results, the processes it involves, everything is just very expensive. Like you have 1 minute downtime, you can just see your salary just disappearing. Like it's extremely expensive. Or the telescope doesn't work for a night. Okay, like €1 million gone. It's like it's really expensive. Everything is so expensive. And despite this complexity, the software development practices that are in our industry are so extremely bad. They're so extremely bad. I mean, there's some fundamental stuff about software development where it doesn't matter what you develop for. Like, it doesn't matter whether you do these web shops or whether you do an Android app or whether you do, like I said, the Mars rover, or whether you do anything. Like, there's some fundamental things in software development that are true for no matter what the application is. And I mean, one thing I'm missing a lot in our industry is the fact that most of the software that automation engineers develop, like the testing phase of it is really at the end. It's only manual testing. Like, all the testing happens when the whole machine is built. And sometimes you have some simulators, sometimes you test part of the machine, but there's literally like no regression testing. There's no automated testing. There's no concept of discussing about test first approach, a fail early approach, or anything like that. Like that is a known thing in our industry, and that's something that I really want to change. I mean, I'm working with this, and this is kind of like one of the things I'm focusing on in my business. Like, how do you apply? I'm primarily doing test-driven development. So how do you apply a test-driven development approach into industrial automation software? Like, the science is quite clear on this, right? There's no fundamental difference, right? And you still want to do this. And I would even argue it's even more important because, the processes, the software you're developing for, it's really expensive, right? The process, so it's even more important. And it's not just about the testability, right? I mean, a big topic in our industry right now, and it has been since I got into it, is what makes good automation software? And it's this big discussion, but I kind of feel like, but just try to start to think about the testability aspect of it first, and you will see gains in these other things as well, like the quality of your software. So I kind of feel sometimes the discussion is on the wrong side, if that makes sense.
Yeah, I think it does. I've felt the same way about a lot of testing. We've had, I don't do industrial automation. I've been in more in, so we say, data engineering and backend and systems programming and some embedded software. And I've always felt in every situation, why don't we factor in the testing more? Because doing rework or suffering the consequences of poor quality is always way more expensive than just getting it right in the first place.
Yeah.
So, yeah,
exactly.
I'm with you there.
And the getting it right thing there. I mean, that's the thing with like, if you don't think about the test cases first, it's what I'm working with. I did a big project now with the pharma company. They really follow this V model. It's so I really didn't like it, and they really tried their best to get all the requirements up front right. And I told them, like, there's not a chance in the universe you're gonna get it right on the first try. We've done this a long time, right? And I tried to, and we quickly did some test cases and everything, and it was very obvious, like, we haven't thought of this. This is where the learning happens, right? When you actually think about the problem you're trying to solve and not try to solve everything up front. And so irrespectively of the quality of the software, there's still even if you don't care about that for whatever reason, there's still gains to be made in the project management, right? For the quality of the software, if you think about that. And that's what I'm missing in industrial automation. This has started to come up, but it's nowhere near from this as where the discussion is in the software field. And whenever I watch this YouTube video, including your videos, and you talk about testability, and we could do it with we have these tools. Now the tools aren't that important, but you talk about these tools, I always feel like this discussion is missing in our industry.
Yes, we as you say, the benefit of doing test-driven development and writing your test first is you start to think about what should it do, what are the edge cases. It's not so much, the tests on Artifact we produce as a consequence, and they document some of this. It's that thinking, it's that feedback loop that people miss is so important versus writing your tests at the end. Again, it's every part of software we've seen time and again that those feedback loops matter, whether you're doing lean development to build a product, whether you're doing agile to ship it and ship the highest value, or we're doing test-driven development. It's really all about creating that feedback loop so we get that idea of what works, what doesn't, what should we build, what's valuable to build, when should we build it, what didn't we know. It's all about the learning, which time and time again gets missed.
That's the point. All about the learning. You pointed on all about the learning, which is a key word in all of this. It's all about the learning. And the other thing you mentioned is the edge cases. What I traditionally see is, if you don't do a fail early approach or a test early approach, is that you only think about the happy case. And I know this from experience now, quite some decent experience, where people test the software, but they test the happy case and a few of the edge cases. But everything else you're handing over to the end user, and I think we could do better. And I don't think we should blame our buyers either. I don't think it's all on the buyers saying, but we didn't get all the requirements. We didn't get, when we shouldn't, because we can't. And even if we did, at some point an LLM is going to replace you, because if someone could give you all the requirements up front, why would they need you in the first place? So it's really. That's the discussion I'm missing in industrial automation, and people tend to focus, and it's the same in the IT industry. Like, people tend to focus on the tooling and the languages and all of this, and I'm like, I don't care about that. We're at the wrong end of the discussion here.
I think part of the problem there is that when we talk about the tooling, somebody can build and sell that. When we talk about getting certified in Scrum or whatever, somebody can build that and sell it. When we talk about you have to do this hard thinking and have these conversations and feedback loops, there's nothing for anybody to sell. There's nothing for anyone so it's those of us that recognize the value advocating for it against people who have an agenda to sell something, or simply don't want to do the hard work, or don't want to incur the costs of that thinking.
I never thought about it this way, but you're right. I never thought about it this way, because I fundamentally been thinking, why is it so that people are actively avoiding these discussions. I don't know whether it's avoiding. It's like they're thinking that they're avoiding it, but like, why isn't this a bigger thing? So, and I think this is definitely something I haven't considered. You have a point.
Well, something for us to think about and see if we can address the problem in the future. On a different topic then, so if somebody is, I don't know, maybe somebody that can't find a job in web development, didn't realize industrial automation exists, or somebody that has had enough of web development and keep chasing the latest JavaScript framework and fancies industrial automation because it sounds fun to control big industrial robots, how could they get into this? What's a good way of them learning more about and building a career in industrial automation?
You're not going to have the problem with the latest web frameworks. You're not going to have a new JavaScript framework every month or however often it is. Industrial automation moves slowly. Like the latest standard we have, the 4th edition of the ISC standard I mentioned in the beginning, came out last year, and the one before that came out 10 years before. So there's been 4 releases, and the standard updates every 10 years. That's how fast it moves. The tooling, I would say now it changes fast, but prior to the last years, it was also just as slow, like nothing happened. Everything was very... So if you want stability in that sense, then industrial automation is the way to go for now. And definitely not that things are changing fast now. It's a really interesting time to get into industrial automation, more interesting than ever. And I don't say this, of course, could always have been true, right? But I really feel there's something bubbling here in the field. To get into it, of course, there's lots of resources. Industrial automation is not as open as the IT field, I would say. People tend maybe not to share their knowledge as much, not because they're mean or anything. It's just that the tooling to get into industrial automation is typically associated with high licensing costs, right? So if you want to do Siemens, as I mentioned, TIA Portal, it's like, thousands of euros every year just for running the license. I mean, it's ridiculous. You have to buy their, and this is critique to Siemens and a lot of other brands. You literally have to buy and pay for the tool that you have to use to program only their hardware. You can't program any other hardware. You can only program their hardware. And this is, of course, a hindrance to people getting into industrial automation. So I want to really kick Siemens here and say, like, people watching this video, if you want to get into Siemens, you're going to have a hard time because there's a big entrance barrier. They have some trials and everything. So there's a couple of YouTubers for Siemens doing this. Of course, I will recommend my YouTube channel. I've spent many, many hundreds of hours creating a very deep PLC programming course using something called Beckhoff. I don't want to mention just them because, I've come into this unfortunate situation where people think I'm working for Beckhoff. I don't get paid by them or anything, but that's kind of like a low entrance barrier because the reason is because with Beckhoff, you can use the development of engineering, everything is free. And it's based on more traditional programming tools like Visual Studio. And, it's much more open in that sense. So you can watch my YouTube course. Everything else is pretty much locked down on courses, and they're in industrial automation. They're quite expensive, and the reason is simply because it's not beginner friendly. Because typical people that going into these courses, they're already hired or working somewhere, and then the company pays for that training.
So what about if somebody wanted to get into one of those companies? What would be a good way of breaking into this career and into this industry?
A good way to get into this industry is, of course, now there's a golden opportunity, and I see this more and more where if you look at some of these companies, if you look at the more modern ones applying industrial automation, so if you look at Tesla and these things and these companies that people more maybe associate to the new generation of manufacturing or whatever you want to call it, they are much more prone to hiring people that maybe have a slightly more software background in the sense. And, learning the industrial automation stuff, it's really not that hard. I don't think that's the important things, to be honest with you. Of course, the things about learning what's the difference working with a web shop versus working with a real-time system, and what does it apply? What does it apply for my communication with all these devices? But it's really not that hard. It's really simple. And that's something you can literally just look at my YouTube course and learn. It's I would say the fundamentals that people have from good software development practices is what matters more here. And this is no matter what language or what background you have, right? I would say if you're a web developer or if you're working with developing software for smartwatches or whatever, if you have these practices of thinking test first, for example, that's a very good start for you. With that being said, most jobs are not like this. Most jobs are the traditional programmer, and then what I would say is really experiment. Really experiment. Run this at home. What I did before I got into industrial automation, I did something to water my flowers. And what does it mean? How can I build this? What do I need for this to do? What hardware do I need? What can I buy this secondhand? Can I build something myself? How do I get into the development environment to actually be able to run this on real hardware? And that's not so tricky. I must say, industrial automation is, the software part of it is just a small fraction. Like most of my time when I do commissions, it's a lot of electrical and wiring. It's configuring drives. It's setting up parameterization. The mechanical engineering side of it is huge, which I don't work in at all. So industrial automation there's much more things you can do than just do programming with it.
Cool. It sounds like it's a big field and potentially growing and becoming more interesting, more modern, and worth thinking about if you're a software developer that's not having any luck at the moment, finding something in the web, getting into software development. Oh, if you want to see your software controlling real machines and building things, which is pretty cool when you get to go in a factory and see some of that.
Yeah, it's one more thing. I just wanted to say that's the best thing with industrial automation. That's why I know I will never go back to the traditional IT world. It's just really nice to see things move, big machines move. And it's nice. It gives some nice feeling inside where you write software that controls something that costs millions or potentially billions of euros. It's really, when you go to bed, it just feels, okay, that was nice. That was a good day. So, yeah.
Cool. Awesome. Well, thank you very much for sharing your experience, Jakob. If anyone wants to learn more, wants to get in contact, apart from your YouTube channel, which we'll link in the description, where else can they find you? How should they get in touch?
They can go to my website and just click on the contact me link there and write me an email, and also contact me on LinkedIn. And people are welcome to write to me. I'm very happy to discuss about this topic.
Okay, cool. And we'll put all those links in the show notes afterwards. Thank you very much, Jakob. Been a pleasure.
Thank you very much.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.